Okay, new type of function. This year we've looked at radical functions, we've looked at polynomial functions, we've looked at trig functions. Now what we're going to do is we're going to look at something called an exponential function, which actually has quite a bit of application in the real world, because there's a lot of stuff that involves exponential growth or exponential decay. Okay, so how do you recognize an exponential function? Well, there's a variable in the exponent of the power. Okay? And it usually takes this one. Y or f of x equals c, where c represents some constant number. So it could be 2, 3 that you see we're about to graph. Okay? To the x. That's the most basic one. We're going to talk about transformations like we did with radical functions and like we did with trig functions. What happens if there's another number in front here? What happens if there's, this is being, if we're adding 2 to the exponent? What happens if we're adding 2 to the end? That changes, that transforms the function. Okay, so this is the most basic one we're going to worry about today. And just keep in mind, we're not going to use negatives for the basis. We can use negatives for the exponents, but not for the basis. Okay. Okay. Let's look at what a couple of these things look like. So a very basic one would be y equals 2 to the x. Best way to see what it looks like, do a table of values. So I'm going to use -2, -1, 0, 1, and 2. And we'll do the same thing for 3 to the x. So let's go to ones that we are familiar with first. So if x is 1, what is 2 to the first? 2. If x is 2, what is 2 to the second? 4. If x is 0, what is any number to the 0? 1. Now these last two, you got to remember your negative exponents. Do we remember what 2 to the -2 is? Remember, to change a negative exponent to positive, put it under 1. So 2 to the -2 is the same as 1 over 2 to the +2, which is 1 over 4. So following that reasoning, 2 to the -1 would be 1 over 2 to the +1, which is 1/2. All right, let's graph these points. So -2, 1/4, pretty close to the x-axis. -1, 1/2. 0, 1. 1, 2. And 2, 4. It's acting up again. Okay, there we go. So you can see that it takes a curve shape. Okay. Now, if we kept going, well, 2 to the 3 is 8, so it's up here. 2 to the 4 is 16, so it goes even higher. So it's climbing like this. You got to be careful with what's going on as it goes to the left, though. As it goes to the left, okay, 2 to the -3 is 1 over 2 to the 3rd, which is an 8. 2 to the -4 is 1 over 2 to the 4th, which is a 16. And then a 32nd, and then a 64th, and then 128. Will it ever hit 0? No, It won't. So it's going to go along the x-axis, getting extremely close to it, but never touching it. Do you remember what we call a line that a curve approaches but never touches? We did talk about it briefly last year. Asymptote. So what we have here on the x-axis is a horizontal asymptote, and I'll write that below when we talk about the properties. So this is a completed graph. The completed graph must include the asymptote. If you just sketch this, it's not fully complete. Okay, what about 3 to the x? Well, should be pretty easy. So 3 to the negative second is the same as 1 over 3 to the positive second, which is a 9. Small, but will never hit 0 if I keep going lower into the negatives. 3 to the first, negative first, is the same as 1 over 3 to the positive first, which is a third. 3 to the 0 is 1, 3 to the 1 is 3, 3 to the second is 9. So negative 2 1/9, it would be extremely close. Somewhere around there. A third, it would be a little bit lower than a half. Notice at 0, it's the same point, 1. And then it's 1 3 and 2 9. 2 4 6 8 9. Still a curve shape, but a bit of a sharper curve. Times quicker. And decreases faster. So you can see what that's going to look like. So if we did 4 to the x, it would be like this. If we did 5 to the x, it would be like that. So the higher the number is in the base, the quicker it climbs and the quicker it gets to 0, or it goes to 0, but never touches. So keep in mind these properties with exponential functions. Okay? Each of these graphs, doesn't matter what the base is, if it's y equals c to the x, will always pass through the point 0, 1. Always. Each of these graphs has no x-intercept because it never touches the x-axis. It gets close, and you keep getting to the negatives, but it never touches. What would the domain be of these ones? Furthest left to furthest right. What's the x-coordinate to the furthest left? The arrow says it goes on forever. What's the x-coordinate to the furthest left? Don't make me walk out of the classroom. Stop it. Come on. What? Negative what? Negative 1 over infinity? 1 over infinity? Negative infinity. What do you mean? It goes to the left forever. And to the left forever is negative infinity. I don't have far to go this way. So where do I go? Infinity, thank you. Range, lowest to highest. What's the lowest value, but never touches? What's that? No? Interval notation, you guys. Come on. We did a whole bunch of these in grade 10, 11, and 12. What's the lowest point, but it never hits it. Zero. And if it doesn't hit it, we put a parenthesis around it. That means we don't include it. What's the highest? Infinity. Thank you. I already talked about this. There exists a horizontal asymptote at y equals 0. And the graph increases to the right. When c is greater than 1. But we're going to see in a second, if c is a fraction between 0 and 1, so if the base is 1/2 or 1/4 or whatever, it actually decreases to the right. Like I said, I'll show you that right away. Okay. So let's look at a couple more. Really, the only one, when you graph these things, like remember when we did radical equations, I said do 0, 0, 1, 1, 4, 2. Well, for exponential, do x is -1, x is 0, x is 1, because you know it's curved. So for this one, we don't have to do a whole bunch. So if x is -1, 4 to the negative first is the same as 1/4 to the positive first, which is a quarter. 0 is 1 and 1 is 4. That's enough to get our graph. So we're here, here, and here. And we know that it's curve shape, and we know that there's a horizontal asymptote at the x-axis for y equals 0. So it's going to look like this. But what if the base is 1/4? Well, 1/4 to the 0 is still 1. So we know that doesn't change. What is 1/4 to the first? 1/4. So notice it's reversing. What is 1/4 to the negative first? 1/4 to the negative first is the same as 4/1 to the positive first, which is 4. So they're actually horizontal reflections of each other. It's going to look like that. Okay, let's just look at a couple more examples. Here's one that's graphed to you. What do you think the function is? Well, it's going to be y equals something to the x. We know 0, 1 is a point. Can you find another point? Like where it goes through an intersection of the grid lines? It might be a little hard to find.
Is it 1, 5?
1, 5. And actually, if you go all the way up here, it's going to be 225 is another point. So therefore, it'd be y equals 5 to the x. Yeah, looking at this point doesn't help because they're all 0, 1. So we got to find other points to the right. And we can't look to the left because it's way too hard to find. It's way too hard to see. Like there's no way you're going to be able to tell this is 1/5. Okay, the last thing I want to talk about, and a couple of you will be familiar with this, here's a really good place where we use them. Where you guys will use this at some point, either as part of your job or when a financial advisor explains it to you. Because you're eventually going to start putting away money if you already started, and that money's going to grow. Except for these days, with those tariff things, it's not growing. Anyway, I'm going to leave that one alone. So what we can do is a lot, when you invest some money in a bank or another company, okay, they pay you to invest. And the amount they pay you is something called interest. So what they do is say, if you invest $5,000 into a bank, and they say, okay, we're going to give you 5% a year. So that means at the end of the first year, you get 5% of $5,000, which is $250, and then that's added to your investment. So your investment after the first year, your total investment is $5,250. At the end of the second year, they take $5,250 and times that by 5% and add that to your investment. So notice interest is being calculated on previous interest that you've earned. That's exponential. Okay, that's the very definition of exponential. It doesn't go up, your investment won't go up like this because you're not getting 250 constant amount every year. You're getting 250 and then you get a little more and then a little more and then a little more and then a little more. So it's an exponential graph. So let's look at this one. You've got an investment of $4,000, earns 4% a year, compounded annually. All that means is interest is calculated once per year. We want to see what this thing is going to be worth, what this investment is going to be worth after 5 years. Okay, so you've decided you got $4,000 you want to invest. You're going to leave it alone for 5 years. You're not going to touch that amount. You're only going to touch it at the end of 5 years unless you decide to reinvest. Okay? So what is it going to look like? It's going to look like this. So we're going to do some columns. End of year. The initial amount you invest is called the principal. So the principal in this is $4,000. Always. And then we're going to calculate how much do you have in principal and interest. So at the end of year 1, well, the principal is $4,000. How do you calculate your interest? You do 4% of 4,000 and add it to the 4,000. But there's actually an easier way. There's one operation you can do to calculate. Instead of going times 0.04 plus 4,000, what could I do instead? No, 1 point. Right. That's okay. That's a quick way to find your principal and your interest, because Like, think of this as a percent. Your investment is going up by 104%. You're getting the 100% of that 4,000 and 4% of 4,000. So how do I find 104% of 4,000? Move the decimal twice to the left to change it to decimal, multiply. So when I do that, I'm going to get $4,160. So just by leaving your money there for a year, you made 160 bucks. Maybe not a lot, some of you. But watch what happens. End of year 2. Well, remember our principal is still 4,000. This is our amount after year 1, right? What do I do now to this to get the amount after year 2? Like for year 1, I do 4,000 times 1.04. For year 2, I do 4,000 times 1.04 times 1.04 again. Okay, because this is year 1. That's how much you made in year 1, 4160, and we're going to times that by 1.04 again. So when we do that, we get $4,326.40. Notice we didn't make 160. We made a little more than 160 that year. Yep. Because the principal is always 4,000. Like it stays at 4,000. No, but this is principal plus interest. This is principal plus interest. The part of this that's the principal is always 4,000. Okay? You should be able to see a pattern developing. How would I find the total interest after year 3? Just times another 1.04. So 1.04 times 1.04, that's the end of the second year. For the third year, we have to times another 1.04. And we get $499.46. Not bad after 3 years. You've made 500 bucks by doing nothing, except leaving an investment. At the end of year 4, what would you do to calculate your principal and interest? Like take this and multiply by another 1.04? Okay, I don't want to keep writing these. Not times 4. How can I write 4 1.04s being multiplied by each other? To the power of 4. That's a little easier, especially if we're going to start calculating. If we leave it for like 10 years, I don't want to keep writing this out all the time. I want to save myself a little bit of time. So that's going to get you $4,679.43. And finally, at the end of year 5, what would you multiply the 4,000 by? 1.04 to the power of 5, yes. And your investment would be worth $4,866.61. So you made over 800 bucks. And at the end of 5 years, you can decide, okay, I'm just going to take the interest out, the 866, and I'm going to leave the 4,000 in and let it grow again. I mean, this is what people do to earn money in addition to their jobs. they invest. And depending on how you invest or what you invest in, the interest that you get changes. If you invest in a savings account at a bank, it's very low interest. If you invest with mutual funds, with a financial company, you could be gaining like 12%, 15% a year. It all depends on how the market's doing. Okay, right now it's lousy. But before a certain person came around again, it was actually doing quite well. Anyway, so there's a shortcut that we can use. There's a formula that we can use, an equation. To find the amounts of an investment, we take the principal times 1 plus the interest rate in decimal. Raised to the number of, do you notice, what do you notice this is the same as? The years, right? So if you wanted to find 15 years, you would just put 15 here. You don't have to worry about figuring it out. So to the number of years. Or, because we use math notation, we would say capital A equals P times 1 plus little r raised to the n. So for example, let's say, to finish this one up, let's say we left it for 10 years. How would we figure out 10 years? Well, the amount would be the $4,000, the principal, times 1 plus 0.04 raised to the 10. Can somebody do that? And round it correctly to the nearest cent? $5,920, 28, 5,920, 98. Thank you. That's not bad. Getting close to $2,000 you made. Half your investment if you left it after 10 years. Okay. And some people leave investments for a long time. I mean, if you have children, you'll set aside money for a lot of parents set aside money for their children's education. So when a child is born, they'll put like $5,000 into some investment account. And when does the student get that money? After how many years? 18. So imagine doing, like, let's say they put 5,000, and this is a very conservative amount. And if you did 18, that's pretty good. Okay, you're going to be likely over double your money, and that'll pay for a fair amount. So here's a really good area where exponential functions are used. Okay, is in finance. So you may not be calculating these yourself, but if you have a financial advisor doing it for you, you sure as heck would want to know what they're talking about. Okay. So having a background in this would certainly be helpful. Okay.